조나단 로메로 폰탈보 자파타 컴퓨팅 설립자 겸 프로페셔널 서비스 부문 이사님을 모셔보도록 하겠습니다. 양자 컴퓨터에서 양자 시뮬레이션과 인공지능을 위한 알고리즘 개발에 중점을 둔 연구를 하고 계신 분이신데요. 양자 머신러닝 어플리케이션의 단기 기업 응용이라는 주제로 강연 영상으로 만나보도록 하겠습니다.
Hello to all the attendees and organizers of the Artificial Intelligence World Congress in Busan, Korea 2022. It is a pleasure to be here. My name is Jonathan Romero. I am one of the co-founders and the Director of Professional Services of Zapata Computing. And today I'm going to tell you about near-term enterprise applications of quantum machine learning. I will talk about the potential of quantum computing and how Zapata is working to help enterprises leverage this potential. Then I will tell you about the software tools that we are building to support the development of quantum-ready applications today, including applications in machine learning. I will illustrate this with an example of a customer in the area of motorsports and close with some final thoughts. So let's get started. Quantum computing is a new computing technology with the potential to provide better solutions to many of the most challenging computational problems in industry, including problems in the areas of optimization, simulation, and machine learning. We are positioned to deliver value from quantum computing, much like big data and AI did in previous technical revolutions. Big data, for example, enable enterprises to collect, store, and make use of their data to make better decisions. Then AI came along, providing more powerful algorithms to do inference. And enterprises were able to use these algorithms to make even better decisions and also to open new markets by the ability of machine learning of solving problems that were previously unsolvable. Now, quantum comes along as a new computing technology, and we expect it to improve the performance of many of these algorithms, therefore being able to provide or to extract even more value out of the capabilities that have been built with big data and with AI. And although quantum computing is still nascent and the hardware is still developing, we see that this developing is accelerating. So as this computer gets bigger and more powerful, we expect them to provide even bigger and better advantages. However, similar to AI, there is not an out-of-the-box quantum application. So to capitalize on the value of quantum, enterprises will need the right combination of software infrastructure, a platform that can help them build these solutions, and also the skills in quantum and quantum-inspired algorithms that are required to develop the solutions, which is something Zapata offers through its services. Now, let me tell you about what makes quantum computers special. So quantum computers are machines that harness the unique properties of quantum systems to carry out information processing. And being a fundamentally different type of compute, it enables the development of new algorithms. Now, some of these algorithms has been proven to provide exponential advantages compared to the best-in-class classical algorithms. And we know that these exponential advantages can be significant. This image on the slide illustrates, for example, how dramatic an exponential advantage can be, to the point that it will allow us to solve problems that for a classical computer might take the age of the universe only in a matter of minutes or hours. This is the expectation that we have for some problems with quantum computing. However, we also need to say that not all the problems will benefit from this exponential speedup. So we are also working on developing techniques and algorithms that help us get advantages, although they might be only polynomial or constant factor advantages in the near term, but still impactful for many of the critical industry problems that we are trying to solve. One of the areas where we believe we can get this type of advantage is generative modeling, as I will mention in one of the later slides. In conclusion, though, our goal is to leverage quantum computing today to improve upon classical solutions at the same time that we get enterprises ready to leverage the power of bigger quantum computers tomorrow. And there are many problems across many industries that could benefit from quantum computing. Just to give you an example of the type of problems that we are tackling, we are investigating the applications of quantum computing in problems such as supply chain optimization for manufacturing industry. The same techniques that we apply to this type of problem might be applicable to other use cases such as portfolio optimization in finance, or many of the optimization problems arising in upstream exploration and production for the oil and gas industry. Some of the enhanced quantum machine learning techniques that I will be telling you about might be applicable to problems such as could be used for improving imaging analysis. This is applicable to many industries, but we are thinking about applications, for example, in the healthcare sector. These same techniques could be also used for improving molecular design for drug discovery. A similar problem can be found in the chemistry, for chemical industry, for problems such as materials discovery. And in this case, we also expect quantum computers in the future to help us improve the simulation of chemistry systems, which will benefit both materials and drug discovery. But in general, and in particular for machine learning applications, the techniques we develop could have impact across many, many industries and for many problems. For example, many of the machine learning problems involved in training autonomous vehicles. So as you see, many enterprises could benefit from quantum computing, which is what motivates the final goal for Zapata. So Zapata Computing was founded to solve the enterprise's most computationally complex problems using quantum computing and also leveraging the wide range of quantum computing technologies that we have today. Our view is that customers do not necessarily need to wait for quantum computing hardware to mature in order to start getting advantages from quantum-ready applications. We could get these advantages by identifying better ways in which we could solve these problems using techniques such as quantum-inspired methods and also leveraging near-term quantum computers. So our final mission is to deliver first-mover quantum advantage to our enterprise customers. And what we mean by this is being able to outperform existing classical solutions in a way that gives them a competitive advantage even before a purely quantum advantage is available. Our goal is always to maximize the benefits that our customers can reap from getting quantum ready. And that implies exploring also techniques such as quantum-inspired methods and heterogeneous compute. So as you can see in the slide, we're working with many customers across many industry domains. And you might ask, what do we exactly do with these customers? Most of the work that we do with them focus around developing these quantum-ready applications for specific use cases. And that development is supported by our intellectual property and our research, and also by our software platform, Orchestra. So it really starts with the IP and the research that we do to understand how to get the most value out of the proprietary techniques that we have developed in the quantum and quantum-inspired space, and how we can better use quantum and classical hardware to increase the performance of these solutions. This encompasses Zapata algorithms and also the applications libraries that have a specific tasks that we can use to build these enterprise solutions. Now, in order to build those solutions, we use the platform Orchestra that has different features that allow us to put together this task in the form of a workflow, which is the fundamental piece or the fundamental concept that we use at Zapata with Orchestra to design these solutions. And along with the workflow management capabilities, we also have capabilities to deploy these workflows in different types of computes, always trying to optimize the use of this compute towards getting better performance. So we believe that one of the areas where we will probably see advantages in enterprise the soonest will be machine learning. And in the case of machine learning, you can see how these different aspects of Zapata are reflected. So specifically for machine learning, we have a huge team. Actually, our largest research team is dedicated to machine learning. And the work that they do in developing new algorithms is then captured in our QML suite that has our proprietary algorithms in this domain. Our customers can have access today to this suite. And then we use this suite to develop these machine learning applications, which is something we are already doing with some of our customers. As I mentioned, we believe that AI and machine learning are the fastest path to where quantum can be helpful for enterprise and deliver value in the near term. And let me tell you a little bit about what are the specific areas of machine learning where we see this potential being realized. So we are looking in particular at generative machine learning as a prominent candidate for quantum advantage. So what is generative learning? In machine learning, we can differentiate between discriminative learning and generative learning. So generative learning, which is typically supervised, for example, could look at this painting, right, and recognize that it's a Van Gogh painting. So we train an algorithm to do that recognition. Now, the thing with this discriminative learning is that there are already a lot of classical algorithms that are able to do this very well. And you can obtain great discriminative learners using classical computers. And this is an area where enterprises have been able to already demonstrate value using this type of models. Now we have generative learning. So by comparison, a generative model apply to this problem of modeling Van Gogh pictures will be a model that will be capable to generate a painting that looks like a Van Gogh. So this is a slightly different type of task. Instead of recognizing, given a data point, these new type of models will have to generate a new data point that looks like previously observed types of data points. In this case, a painting that resembles the features of Van Gogh paintings. This type of task we have found can benefit from quantum computers. For example, one of the things that we have studied is the expressibility of these models. Turns out that generative machine learning models are in some cases more expressible and therefore can generate richer probability distributions with the possibility of better capturing the features of a given data set. This is one of the reasons why we are focusing on this area for developing our applications. Now, some of you might wonder also, how does a quantum machine learning model look like? So at Zapata, we use many combinations of classical and quantum to solve complex problems. And that also applies to our generative models. So typically, we work with hybrid quantum classical models where a piece of the model is executed or on a classical device and while the rest is executed on a quantum device. You can think of this as an example of this would be a neural network where we have a classical neurons executed on classical computers, and then one layer of this network can be a quantum circuit which is executed by the quantum device. We are also working on quantum-inspired technologies, which are algorithms that run on classical computers, but that emulate properties of how quantum computing works. This type of approach helps us bridge the gap between quantum and classical, and is very useful in research because it helps us identify what are the aspects of quantum that can benefit or improve upon classical solutions. But in some cases, it can also provide already some advantages from which enterprises could benefit today. In general, the approaches that we develop and the solutions that we develop are a combination of classical quantum hybrid, or quantum-inspired techniques. And because of this, we need a set of tools that help us build truly hybrid applications that can be then deployed in this variety of computing technologies. And that's what takes us to the need of having the right tools to carry out these type of calculations. Here's an example of one of the applications in the area of generative models that we have done recently. We published this paper where we generate for the first time high-resolution images using quantum devices. Here we are using an adversarial neural network, one quantum version, a quantum-inspired version, and a classical version of it, and we are using it to generate digits. So we are working with the prototypical MNIST data set, and as you can see in this slide, in this plot, sorry, where we compare the performance of these different techniques, we show how quantum and quantum-inspired models can actually generate better results for these particular instances when compared to classical. We did this using existing quantum devices provided by our partners IonQ and Quantinuum, and you can see here on the right-hand side of the slide an example of the numbers that we generated using the quantum computer, and also you can compare them with what was the state of the quantum state of the art before our work. So you can see how by using these these hybrid quantum classical approaches, it's possible to get results that are in some cases even better than purely classical state-of-the-art solutions. So we are already exploring the application of these quantum-enhanced machine learning techniques to use cases in industry. Another exciting area that we are doing is this intersection between machine learning and optimization. In particular, we're using quantum machine learning models to enhance solvers for combinatorial optimization. We call this approach the generator enhanced optimization, and this is one of the approaches that we are also applying to different use cases with some of our customers. So you are welcome to take a look at the paper cited here to get a better understanding of these approaches. However, I want to point out that in order to now apply this for enterprise customers, then we have the challenge of the infrastructure, how we're going to build these applications, how we're going to integrate these algorithms to the existing software pipelines for customers to be able to leverage these techniques. Here is where Orchestra gets into the picture. So we are developing Orchestra, our software platform, with the goal of supporting the development of these applications, and that is the first layer in the structure of Orchestra. So now, to build these applications, we are taking advantage of the workflow concept that I mentioned before. So Orchestra offers a computational workflow management tool that helps you leverage computational tasks that have been already designed to build this application and construct these solutions. Some of those might be coming from the Unified Quantum SDK that offers a series of basic tasks for operating quantum computers. We also have application-specific tasks, such as the tasks that our research team has designed in the QML suite. We can also leverage open source libraries, for example, PyTorch or scikit-learn in the case of machine learning, to build a specific task that we need for the solutions. Once we have built those workflows, we need to deploy them to actual computing resources. So we have developed this deployment orchestration tool that helps us integrate different types of compute, including quantum, public cloud, HPC, GPUs, TPUs, other emerging compute, as well as private cloud, on-prem resources, and also edge resources, which are very important for some machine learning applications and other types of applications. We complement this with a management console that help the customers keep track of the workflow execution, the usage of resources, and in the case of the machine learning applications, aspects such as governance and monitoring of the models. And we are building this software platform to be flexible such that we can integrate external services. For example, technologies coming from previous technological revolutions, such as data lakes and classical machine learning techniques and other classical machine learning platforms. All of this is with the goal of supporting the entire cycle of development, from research to development of the applications to deployment. So we do this with our customer by offering our Zapata expertise and the Orchestra capabilities and working with them through the entire cycle by first identifying research use cases, developing prototypes, then measuring the performance of these prototypes and upgrading them to software that can be used in production. And we do this along multiple industry domains, as I have described before. So just to give you an idea of what an engagement looks like in the space of machine learning, we are working with Andretti Autosports, which is a motorsports company in the IndyCar series in the US. We are exploring with them the application of machine learning and quantum machine learning techniques to solve some of their problems that they have. So motorsports is a very exciting field for machine learning because it has a lot of challenges. You have to make inference very quickly. There is a very fragmented data infrastructure. You also have restrictions in the type of compute that you can use. So a lot of the stuff that we are developing for them, we are pretty sure will be applicable to other industry domains. So the approach we are taking with them is that we are helping them build capabilities across many of these different technological revolutions. So we are starting by putting together the data infrastructure, big data. That infrastructure will enable us and their teams to seek together, identify use cases, and develop machine learning algorithms to tackle those use cases and give them a competitive edge in racing. And once we have developed some of these algorithms, we will also explore how quantum computing can enhance some of these algorithms to drive or to get even more advantage out of the models that we are building. So we are doing big data and classical machine learning today, and tomorrow we will explore quantum power race analytics. To close, I will leave you with a quick comment on the importance of becoming quantum ready. Andretti is one of those companies that exemplifies the need for becoming quantum ready and recognizes that need. We carried out a survey together with Wakefield Research of over 300 different global leaders at a VP level in different enterprises. And 74% of them agree that those who fail to adopt quantum computing solutions will fall behind. This is not different from previous technological wave where, for example, the people that first adopted big data, first adopted AI, were the people that got more value out of it. So this speaks to the need for getting quantum ready today. So just to close, remember, quantum computing is the next technological revolution, and Zapata is positioned to lead in quantum software and help companies unlock the value of quantum computing. With that, I would like to thank you for your time today. And if you have any questions post-presentation, please reach out to my email, which is listed here on the slide. And if you are interested in learning more about our research and our work with our customers, follow along our social accounts at Zapata Computing. Thank you.